Hello and welcome to our notes on calculating slope in linear relationships. So in class we've been talking a lot about linear relationships. We've been making tables, we've been graphing these lines and writing equations, and we've talked about how that constant rate affects the slope of a line. So what we're going to do today is we're going to find the slope of the line even if we're not given the slope in the story, in the description. We're going to calculate slope by looking at the line on the graph. Okay? So let's start out here. Here it says the relationship is linear if the rate of change, or the slope, is constant. And this is something we've been talking about quite a bit. How you know that a relationship is linear if there is a constant rate of change. Okay? Specifically today we're going to talk about the slope formula because we can find the slope even if we're not given it right away. So let's say we've got a graph and we've got a line similar to maybe Alana's line in the pledge plan. Okay, so we've got something that looks like this. Now if we're not given the slope right away, we can calculate that slope. Okay, and what we need to do is we need to know 2 points on the line, so some xy coordinate here, and then a second point somewhere else along the line. And if we know 2 points along the line, we can calculate the slope. And what we're going to do is we're going to call one of these points x sub 1, y sub 1, and the second point we're going to call x sub 2, y sub 2. So these are called subscripts to differentiate between the first point and the second point. Okay? So the way we're going to find slope, the slope formula is defined as, we're going to fill it in here in the box. The way you calculate slope is that once you know 2 points, you're going to do y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now these little 1s and 2s don't mean the number 1 or the number 2. It just means that this variable x is different from this variable x. I want to use x to show that it's the x coordinate, but I have 2 different x coordinates. So these are called subscripts. So I subtract my y, and then I subtract my x, and I divide the 2. It's like finding a ratio. Okay? So in other words, when I subtract the y's, I see how far I'm going up compared to how far I'm going over. Because when I subtract the x's, it's going to go this way. So when I'm subtracting the y, I'm looking at how far it goes up, or it's called the rise. When I subtract the x's, I see how far it goes over. That's called the run. Okay? So another way of describing this is rise over run. Okay? Or often we talk about this as the vertical change. Vertical change divided by the horizontal change. Okay? So if you're not already given the constant rate, we can calculate it by picking out 2 points from the line and using the slope formula to see how fast it's going up. Okay? So let's try an example to see how that works. Down here we have 2 graphs for the number of heartbeats over so many minutes. So here it says the graphs give information about a penguin's number of heartbeats b over time t minutes during normal resting and just before diving. When is the penguin's heart rate greater, during normal resting or just before diving? Okay, so let's take a look at the different rates here. So here I have a graph for normal heart rate, beats, and then this is time again, and then this is a heart rate right before diving, the number of heartbeats over so many minutes. Okay, so let's use the slope formula to calculate the rate here. Now in order to use the slope formula, I need 2 points on the line. This one is already labeled for me, 2, 150. I have to pick another point, and I want to pick a point that's easy to see. So right here, I have 0, 0. That's another point on the line. So I'm going to use these 2 points to help me, okay? And I'm going to call this x sub 1, y sub 1. And I'm going to call this one x sub 2, y sub 2. It doesn't really matter which one is which, but I've decided to label this one this way. Okay? So when I find my slope, I know that my slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So I'm going to subtract my y values. I'm going to start with this coordinate. So my y coordinate is the 150. This y coordinate is 0. So 150 minus 0 divided by my x coordinates are 2 and 0. Now since I started with the 150 in the numerator, I have to start with the 2. I go back to that same coordinate. So down here I'm going to do 2 minus 0. Then I just subtract. Here 150 minus 0 is 150 divided by 2 gives me 75. And I'm going to label mine. This is beats here, minutes here. So this is beats per minute. So that's my rate here in this first graph. Now I'm going to do the same thing in my second graph. I'm going to find 2 points. This one's already labeled for me, 2 comma 400. Now I'm going to find another point. I could use the 0, 0, but I don't have to. This point is easy to see. This is clearly 1 comma 200. My x coordinate is the 1. The y coordinate is the 200. Okay? So xy, here's another xy. Okay? So now I'm going to find the slope for my second relationship here. So again, I'm going to do y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, I don't have to start with the bigger coordinate. I'm going to start with the smaller coordinate to show you that I get the same answer in the end. So this time, I'm going to start with 200. So I'm going to do 200 minus the 400 is my other y coordinate, divided by, now since I started with 200, I have to start with this x value, the 1. So it's 1 minus 2. Okay? In my numerator, 200 minus 400 is negative 200, divided by 1 minus 2 is negative 1. Negative divided by negative is a positive. 200 divided by 1 is 200. Beats per minute. Okay? So that means that the heart rate right before diving is much faster. It's 200 beats per minute instead of just 75 beats per minute. But when I look at these two graphs, this second graph doesn't look that much steeper. But if you notice carefully, the y scale, this is going up by 100. This is only going up by 50. So the scales are very different. Okay? So in order to compare them better, if I'm going to erase this for a moment so I can graph it together, what I'm going to do is I'm going to take this data and put it on the same graph. So here, this is 0, 0, and 2, 150. So 0, 0, 2, comma, 150. You see that if I graph them together on the same graph, then you can see that this one is clearly not as steep as this one. So this has a rate of 75 beats per minute. Then the other red line that I'm going to highlight has a rate of 200 beats per minute. Much steeper. Okay? So this is how you use the slope formula to help you find the rate. Let's try another example on the next page. The graphs give information about distance d miles traveled over time, t hours, by cars and trucks on a California highway. Which speed is lower? Okay, so again we have a graph, cars, this is distance and time, and a second graph for trucks, again distance and time. So speed is just a rate. So let's find the rate for each one. So the cars here, again, for slope, I need 2 points. And I'm going to do y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So I have to pick 2 points. This one, clearly labeled, easy. And then this one, 0, 0, is pretty easy point to see. So I'm going to subtract the y values. Remember, this is x, this is y, this is x, this is y. So I'm going to do y2 minus y1. Remember to put the y coordinates in the numerator, divided by x sub 2 minus x sub 1. So I'm going to have 100 divided by 1.5. When I divide this out, the result turns out to be 66.6 repeating. And this is miles per hour. So that's how fast the cars are going, 66 miles per hour. Okay, let's do the same thing for the trucks. So I have 1 point here already, 2 comma 100. Let's find another one. Here, this is an easy point to see. This is 1 comma 50. So I'm going to use these 2 points to find my slope. So I'm going to subtract. Remember, the first number is your x coordinate, the second number is your y. So I'm going to start with the 100. 100 minus 50 divided by, and I'm going to subtract the x's, 2 minus 1. 100 minus 50 is 50 divided by 1. 50 divided by 1 is 50 miles per hour. So the trucks are traveling at a rate of 50 miles per hour. The cars are traveling at a rate of 66 miles per hour. Okay? And again, if we put them together on the same axes, this is 0, 0 and 1.5, 0, 0, 1.5 comma 100. We see that the car's line is steeper because they're traveling at a faster rate. Okay? Right, so what I'd like you to do is try this same technique with these 4 graphs here. So for each one of these, pick 2 points that are easy to see. For example, here 1 point might be 2 comma 1. Pick a second point on this line that you would like to use, and then use the slope formula to calculate the rate. So as you know, the slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So try these 4 examples here for question number 3, and then we will go over the answers in class. As always, if you have any questions, please make a note of them and ask me about it in class. Thank you very much.